Hey everybody, hope all is well. This is BJ 20. Thanks for tuning in. Right now, I'm working on my two custom BJ 20 Autotech engineering alternators. These are high output alternators, 370 amps each. Have my name right there, BJ 20. That's one. This is actually the first one that I bought. This is also the one I had to repair because the rectifier went bad. And I'm going to talk about that as well. And this is the second one that I bought, BJ 20. Now, the reason why I have them, the back pieces, all taken apart is because I took out the regulator, which is right here. This is the one that came standard with it. VRH 2005-94E. Your standard 3 to 4 pin with the lamp, the field, and the sense. People will put the sense on the positive stud of the alternator, and they'll sometimes even put a voltage control module or a sense or some type of resistor, a diode or something in line with the sense to be able to help trick the system and increase the voltage from whatever the vehicle would normally want to a little bit higher. And that's what I was doing all the way up to this point. I had diodes along the sense terminal that would increase it from the standard 14.8 that these charged at to up to 15.8, because when I first got these I was running AGM batteries, and then recently from there got up to lithium. So now I'm running Cmax lithium, and those need to be charged anywhere from 14.8 up to 16.8 max. So 14.8 being the beginning stages of charging for Cmax lithium. These would only charge up to 14.8 standard, being internally regulated with this part here. So I have to use diodes on the sense in order to increase the voltage. Only thing about that is, no matter what I did, even though these are both 370 amp alternators, they're both from Autotech Engineering, this one was always slightly stronger than this one. So this one would go up from, if it's at 14.8 set point, this one will be 14.8, this one will be 14.9. If I went up using diodes, if I went to 15.5 volts, this would be 15.5, this would be 15.6365. So this one will always be slightly higher than this one. And from doing research, what I read up was, when you have multiple alternators charging one battery, especially if they're, no matter what you do, there's always going to be one slightly more than another. It doesn't matter if they use the same exact parts. One is going to be slightly trying to basically take the load more than the other. And I think that's exactly what was going on with mine, causing this one to go bad, which is why I had to repair this rectifier here with the RN, dash 59. So this whole piece right here and these points, I had to unsolder the old one, resolder these, place it down, screw it back up just to get this alternator back going. It currently works, and I'm happy to be able to say that my first time ever doing a repair on the alternator, I was able to get it back into its working status. But since I decided to finally go externally regulated, and this is the Brand X external regulator that I showed in my previous video. This one has two modules. It'll allow up to 4 alternators to be charged at one time, but I only have 2 that I'm going to be controlling, so I only bought 2 modules for this unit. If I ever decide to get more alternators later down the line, then maybe I'll get some more modules and possibly control more with that. But for the time being, I only have two, so I only bought 2 modules for what I have. But with that being said, this one unit going externally regulated instead of internally regulated is going to allow both of these alternators to be well balanced. They'll both be putting out the same exact voltage. Because like I said before, when they were both internally regulated, no matter what I did, one was always slightly stronger than the other. So if I'm charging at 15.9 volts, this one is allowing for 15.9. This one only would allow up to 15.8. And because of that, this one would cut off at that 15.8 mark. And if I'm charging up to 15.9, this is the only one that's technically running. This one decided to cut off at 15.8. This one's continuing to run, which means that I went from having 2 370 amp alternators to now this one says, nah, can't do it. I'm done. And it's only running off that one, putting all that stress on one. But because the system sees 15.9 volts, even though this alternator is not charging, it's still being fed that energy. It doesn't like it. Eventually, you got parts that overheat and go bad. So these components, amplifiers, subwoofers, alternators, just about any electronic, they don't like heat. So from what I was told, talking to people that went externally regulated, watching videos and doing some reading, doing a little research before I decided to go this route myself, they said that when they went from internally regulated to externally regulated, their alternators ran cooler. So not only does it help it maintain and keep it well balanced and make sure that they're both, or however many alternators you have in line on your voltage regulator, they're all evenly putting out the same voltage, but it helps keep them cool because I believe it's a cooler because of that being well balanced versus them fighting each other like what my system was obviously doing before, which caused this one to overheat and internals to go bad. I don't want that to happen anymore, which is why I'm going this route here. So not to keep you guys on for too much longer, I just wanted to kind of give you a little idea as to what I've learned, and it might be able to help some of you maybe possibly get an idea what might be going on with your own systems if you're experiencing similar issues. If you have to keep sending your alternators back, it's probably not the alternator's fault. I can sit here and admit user error. This one went bad on my end, and now I'm trying to do what I can to correct that by going externally and have them be well balanced out. But with that being said, I picked up these here 170-52007. This is going to allow the alternator to convert from internally regulated, this one, over to external. So all I have to do, this little piece right here and this point right there, they're soldered together. They're usually soldered together. And then this brush holder, just like that. It's usually screws keeping this brush holder mounted here and there. The voltage regulator would be mounted here and here, and then it's soldered there. So all I have to do is take off all the screws, pull off the brush holder, loosen up the voltage regulator from these 2 points here, and apply heat from the soldering iron just enough to be able to pull it up. And now with this external part, if you see here, there's no parts, there's no pins to solder. There's no need to. But this one does have 2 legs. And when I watched the video from the owner of Brand X, Jonathan Patrick, he said you have to cut off one of the legs to help the mounting, which is obviously this part right here. Not that one, just this one has to be cut off, because if you don't cut it off, then it's not going to be able to mount down all the way evenly. And it's not going to be able to mount down evenly because that leg there is hitting that mounting area there that the brush holder would normally screw into. So that brush holder screws into there. That part is going to be hitting against the leg. So that leg would need to be cut off. All I did was use some cutters I had. And now if you see, it's no longer in the way. Put the brush holder over like so. It will screw back there. The brush holder will screw back on that side. And this will screw here and there, just like the internal did, minus the fact that you don't have to solder on this one. Put the back piece back on, screw them back in, and get to go. But not to keep you guys here for so long. I'm sorry. It has already been over 11 minutes. But I just kind of had to, talk about what I've learned, and maybe this can help others not to have to go through what I've been through. And if you have been through what I've been through with alternators going bad because multiple to one battery not working well together, then maybe going externally regulated might be best for you as well. It might work good for some. If you have one alternator charging a battery, there's no need for this really. It can help because you can adjust the voltage on your own. You just have to be aware that your vehicle, your amplifiers, whatever electronics you're running, just be aware that whatever voltage you have it at, that they're going to be all safely operating at that voltage. I'm going to be running my system at 16 volts, up to like 16.5, 16.6 if possible. I'm going to monitor to see how high this would allow. Cmax that I'm running runs up to 16.8. I don't want to max it out because I don't want my cells to go bad, so I'll probably go as high as 16.6, maybe 16.7. But that will only be if my amplifiers don't mind that voltage. If my amplifiers decide to go into protection because it doesn't like it, I won't be doing it. So you just have to be aware of what electronics you have, what they like and what they don't like. Your vehicle. I'm running two complete different charging systems. These two being on my audio side, another one being on my vehicle. So what my audio side sees, the 16 volts plus, my vehicle will never see. That's the only reason why I'm doing this. So just be aware for yourself what you're doing, and if this is the best option for you, hey, have at it. All right, everybody. Thanks for tuning in. As always, peace and love. Thanks for watching, and stay tuned for more.